Hello everyone, welcome to my YouTube channel IGCSE&GCE Maths School. Today too I have brought a very important video on upper bound, and in this video I expect to discuss three important points. They are: first one is upper bound, the maximum value. Second one, why is it called the maximum value? Third one, can upper bound be corrected to the given corrected value? Can upper bound be rounded to the given corrected value, right? These are the 3 points. Once again, the 3 points that we discussed once again. First one is upper bound, the maximum value. Second one, why is it called maximum value? And can the upper bound be rounded to the given corrected value? So those are the 3 points that we discussed in this video. Let's straight away go to the video, and what upper bound is has been discussed in one of the previous videos, that is what is upper bound and lower bound. So that was that video. Then I will put the link of that video to the description of this one, and go to the link and watch that video also. Right now, upper bound. Let's say in that what we call video, we define upper bound as the maximum value that can be rounded to the given corrected value. Maximum value that can be rounded to the given corrected value. Right now, but here there is a problem. Whether is it the maximum value? Whether the upper bound is the maximum value that can be rounded to the given corrected value. That is the question. Although we call the upper bound the maximum value that can be rounded to the given corrected value, is it actually so? That's what we are going to discuss. And right now we will open discussion into that. First of all, now the upper bound. Now, I will take an example in the first place. Say 260 is the value corrected to nearest 10. 260 is the value corrected to nearest 10. Right? Now, we will find the upper bound and lower the upper bound formula. Upper bound equals corrected value plus degree of accuracy over 2. Degree of accuracy over 2. That is the upper bound formula. Then we will find the upper bound of it. That is 260 is the upper corrected value. Then plus degree of accuracy is given in the now with the number that is 2 nearest. That's to nearest 10. That means degree of accuracy is 10. 10 divided by 2. Then 260 plus 10 divided by 265. 265. Right. 265 is the upper bound. Now we ask the question: is upper bound the maximum value that can be rounded to the given corrected value? 260. In other words, is 265 the maximum value that can be rounded to the corrected value 260? That's the question. Then we will check. Then we will round this after nearest 10. Then 265 to nearest 10. How much? Then 265 nearest 10, you go tens place. Go to tens place, that is here units, tens, and this is the hundreds. Tens place, the digit in the tens place is 6. Then look at the digit in the units place, that is the digit in the place just below the place of the degree of accuracy, that is 5. As it is 5, add 1 to this one. This according to the rule of rounding off. 270, that is 270. See, if you round this 265, that is the upper bound of this corrected value 260, and the corrected value will be 270. There it is not 270. Actually, if this is the maximum value that can be rounded to the given corrected value 260, after rounding this to 10 to nearest 10, answer must be 260. But we rounded it to nearest 10, but we got is 260. So what we got is 270. Therefore, that is not the maximum value that can be rounded to 260. That is the maximum value. But why is it called the maximum value? That is the important point that we have to elaborate on. Then see, Now you consider some values just below this that can be rounded to 260, like this. Let's say 260, say 264, 265, 264. Now write this correct to nearest, write this correct to nearest 10. Tens place here, look at the unit place, less than 5 and put 0 here, no addition, 260. 260. Then we'll take another one, 264.9. Then round this also to nearest 10. Still how much? This to nearest 10 how much? Nearest 10 how much? 260. This is also how much? To nearest 10, 260. Look at this one again, less than 5, no addition, 260. Then take another one, 264.99. Then again the same thing, 260. If you are, it is rounded to nearest 10. Then take 264.99999 and get minimum 9. Right. Now say any number with what we call 9 in any decimal digit, any decimal place, rounded to nearest 10 will give 260. This is also 260. Then what is the difference between 264.9999999 and 270? What is the difference between, what is the difference between 264.9999 and 260? It's a very infinitesimal difference. It's a very infinitesimal difference because the difference between this the maximum value that can be rounded to 260 and what we call and 260. The difference between this one, the 200. The difference between the number that can be rounded to. Difference between the maximum value that can be rounded to 260 and 265 is infinitesimal difference. Infinitesimal difference. Infinitesimal difference is very, very small. Extremely small difference between this, the highest value that can be rounded to 260 and the upper bound 265. Therefore, as that difference is extremely negligible, we can take 265 as we can call 265 as the maximum value roundable to the 260. 260, right? Okay. Then that's why. Therefore, 270 is not actually, 265 is not actually value roundable to 260, but actually the difference between the highest number that can be rounded to 260 and 265 is, that is the upper bound, is extremely small. It's so small that that difference is negligible. Therefore, we can call it 265. That's why it is called the maximum value. That's why upper bound is called the maximum value. As the upper bound cannot be rounded to the corrected value given, when we write the range of values that can be rounded to the corrected value, we ignore upper bound. We ignore upper bound there. we ignore bound. Here the range of value that can be rounded to the corrected value is given as lower bound less than or equals actual value less than upper bound. When you come to lower bound, the lower bound is one of the numbers that can be rounded to the given corrected value. But when you get the up, that's why it has been put and less than and equal. That's why less than and equal has been put in the range. But when you come to the upper bound, with the upper bound we have put only less than. Therefore, always the actual value range of actual values that can be rounded to the given corrected value must be always less than the upper bound, and it cannot be equal to upper bound, and upper bound is not a value that can be rounded to the given corrected value. So that is the reason actually why we write here actual value less than in the what you call this range of actual values that can be rounded to the given corrected values. So that is all about. I think we answered all three questions. There is upper bound, the maximum value. Actually, it is not the maximum value that can be rounded to the given corrected value. But why is it called the maximum? Yes, but it is called maximum value because the difference between the maximum value that can be rounded to the given corrected value and the upper bound is very, very negligible. Therefore, it can be called the maximum value. Then can upper bound be corrected to the given corrected value? Can upper bound be corrected? Yes, we check upper bound. If you correct the upper bound to the given degree of accuracy, it was 270, not 260. Therefore, definitely the upper bound cannot be corrected to the given corrected value. Right. So therefore, all the three questions have been answered. That's all. Then that is the all about today's video, and we will meet tomorrow in another video, the important video. And until that, I say goodbye to you, and don't forget to subscribe the channel and share and like and comment on the videos. Then always stay with us, subscribe the channel, and we are putting videos daily on mathematics for your examinations. Thank you very much. Have a nice time. Goodbye.